Okay, good morning, my dear students. Welcome to our 6th online session for Calculus 2. And this morning, we will study about the derivatives of your inverse trigonometric functions. The basic, which are sine, cosine, tangent, and the reciprocal functions secant, cosecant, and cotangent are the trigonometric functions. The inverse trigonometric functions are your arcsine, arccosine, arctangent, arccosecant, arcsecant, and arccotangent. Now, what do we mean by arcsine, the arcsine function? Okay, what's your understanding of the arcsine function? Okay, the arcsine function is the inverse of the sine function. So, for example, if we say arcsine of y is equal to x, it gives angle, okay, the angle whose sine value is x. You know very well that sine of 30 degrees is equal to 1/2, okay, or 0.5. So, sine of 30 is 0.5. When we say then arcsine, okay, arcsine of 0.5, we mean what is that angle, okay, whose sine value, what is that angle whose sine value is 0.5? It's 30 degrees. Okay, so arcsine of 0.5 is equal to 30 degrees. Okay, so that's the meaning of your arcsine function. Okay, you know very well also that cosine of 60 degrees is also equal to 1/2. Okay, remember from your trigonometry that sine and cosine are co-functions. Okay, remember co-functions, complementary functions. Complementary functions. What do we mean by this? If you have cosine of alpha is equal to sine of beta only when alpha plus beta is equal to 90 degrees. Okay, co-function from the word complementary. And when are two angles complementary? When their sum is 90 degrees. Okay? When the sum of the two angles is 90 degrees. So, your sine of 30 degrees, therefore, is equal to cosine of 60 degrees. From here, I could write arccosine of 1/2. What is the meaning of this? What is that angle whose cosine value is 1/2? And that angle is 60 degrees. Okay? So, the answer here is also 60 degrees. But, there is another way by which we can write this. You don't have to spell it out, okay, completely, okay, because this is represented by sine raised to -1. Please bear in mind that this is not equal to 1 over sine. Okay? Please keep this in mind. That sine raised to -1 is arcsine. Okay? So this one is arcsine. Because 1 over sine is cosecant. Okay? Remember from our previous lesson or from your trigonometry that 1 over sine x is equal to cosecant x. Okay, 1 over sine x is equal to cosecant x. So, this is never equal to 1 over sine x. Put that in mind. Next, your arccosine is also abbreviated as, arccosine is simply cosine raised to -1. Your arctangent is tan raised to -1. Arccotangent is cot raised to -1. Arcsecant is secant raised to -1. And arccosecant is cosecant raised to -1. So, we mean finding the angle, okay, whose values, sine value, cosine value, tangent, cotangent value, cosecant, secant values are given. Now, the following are the formulas for your inverse trigonometric functions. The derivative of arc sine of x, here, the derivative of, may we proceed now to the next slide? I want you to pay attention to the first now. The derivative of arc sine of x is equal to 1 over the square root of 1 minus x squared. Okay, such that x should not be equal to positive or negative 1. Why? What happens when x is positive or negative 1? Take note that in the denominator, we have 1 minus x squared. If x is 1 or negative 1, what happens to the denominator? It becomes 0. So that is not possible. Okay, for arc cosine of x, its derivative is the negative. Okay, the negative of 1 over the negative of the derivative of arc sine. Okay, so the derivative of arc cosine is the negative of the derivative of your arc sine. Negative 1 over 1 minus x squared. For arc tangent of x, we have 1 over x squared. For arc cotangent, the negative of. Okay, again, these are co-functions. Okay, one is the negative of the other. In like manner, tangent and cotangent are co-functions too. Look at their, okay, derivatives. The derivative of cot is the negative of the derivative of arc tangent. In fact, sine, and look at the name, cosine. See? Because these two are co-functions. And look at this pair also. This is tan, and this is co-tan. See this? They are co-functions. Next, in like manner, the derivative of arcsecant of x is 1 over the absolute value of x times the square root of x squared minus 1. And the derivative of arccosecant of x is negative 1 over the absolute value of x times the square root of x squared minus 1. Again, this pair are also co-functions. Okay, co-secant, cosecant. Okay, now let's show the derivation of the formula so that you don't have to memorize. So that if you know one, then you can derive the derivatives of the rest. Okay, so you don't have to memorize. You can show the proof on your own. Now, let's begin with y equal to arc sine of x. Okay, and to differentiate, we will apply implicit differentiation and derivative of your trigonometric functions. Okay, let's look at, prior to that, let's look into the general form first. If the argument, by the way, if the argument, okay, is no longer x, but a function which is still differentiable, okay, represented by u, then the derivative of arc sine of u will be, you can have here du, but it's okay, you can write it this way, 1 over the square root of 1 minus u squared times. Okay, remember that I said a while ago that u is still differentiable. We have to get the derivative of u with respect to x. Okay, so in like manner, if the argument of cosine is no longer x but a differentiable function represented by u, then its derivative of arc cosine u is equal to negative 1 over the square root of 1 minus u squared times the derivative of u with respect to to x. Okay? And so with the rest. So if the argument is still differentiable, then by your chain rule, we still have to differentiate u with respect to x. Okay, now we are going to prove the first formula. Prove that the derivative of arc sine of x, okay, the derivative of arc sine of x is equal to 1 over the square root of 1 minus x squared. Okay, so let y, the function, be arc sine of x. Okay, arc sine of x, or y is equal to, okay, so which means that sine of y must be equal to x. Okay, so from here, sine of y must be equal to x. Okay, remember our description of an arc sine? Arc sine gives the, okay, arc sine gives the angle. Okay, the angle whose sine value is this. Okay, whose sine value is x. Okay, so looking at this, sine y is equal to x. We will now apply implicit differentiation. Okay, by finding dy over dx. Find dy over dx. Okay, go back to your previous lesson. To our previous lesson, what is the derivative of sine y? Okay, the derivative of sine is cosine. Okay, so this is equal to cosine y, and since we are differentiating the variable y from your chain rule, okay, and implicit differentiation, we also have to get derivative of y with respect to x is equal to derivative of x, okay, derivative of x is equal to 1. Okay, now solving further for dy over dx, okay, dy over dx is equal to 1 over cosine y. Okay? 1 over cosine y. Now, we'll assume that let y be an acute angle of a right triangle. Okay? Now, from here, from the given, okay, let's prepare a triangle wherein one of the acute angles is y. Okay? In which one of the acute angles is y. Now, remember your definition of sine. Okay? Remember that when we speak of sine theta, it's the ratio of, so, opposite over hypotenuse. Yes? Okay. Opposite over hypotenuse. And this is our reference. So, sine y is equal to x. But I could express x as x over 1. Okay? So, which means this is my opposite side with respect to the angle y, and this is the hypotenuse. Okay? Opposite and hypotenuse. So, let me draw Let me draw a right triangle. Okay, let this be the right triangle. And like what I said a while ago, we let y be one of the acute angles of the right triangle. Let this be y. Let this angle be y. Okay, so if this is angle y, which side is opposite? Okay, opposite. This must be x. Okay, and the hypotenuse must be 1. Okay, but take note that a while ago we ended up with cosine y and we want to find out what cosine y is. We want to find out what cosine y is from our right triangle. Okay, so we can now define cosine y. So if this is 1, if this is x, one side is missing, yes? This side. Let it be b. Let this be b. Okay? Now, remember from your Pythagorean theorem that the sides of a right triangle are related according to the relation a squared plus b squared equal to c squared. So, from your Pythagorean theorem, a squared plus b squared equal to c squared. So, what's your a here? A referring to the altitude, which is, let this be x squared, okay, plus, okay, b squared is equal to, what is our hypotenuse? Our hypotenuse is 1 squared. Okay, what are we looking for? B. Okay, so b must be equal to, or b squared rather, must be equal to 1 minus x squared. And if we get the square root, b equal to the square root of 1 minus x squared. Okay, so this side is equal to the square root of 1 minus x squared. But, what are we looking for? We are looking for this. Okay, cosine y. So now we are ready to define cosine from here. So from here, cosine y, okay, by definition, cosine is equal to ka. So ka adjacent over the hypotenuse. Okay, so your cosine y will now be side adjacent to angle y. The side adjacent to angle y is this. Okay, so square root of 1 minus x squared over the hypotenuse which is equal to 1. So I may not write it anymore. Okay? Or it's alright. Over 1. So your cosine y is equal to the square root of 1 minus x squared. So going back. So now we can continue. So your dy over dx then is equal to 1 over, what is cosine y? What is cosine y here? Okay, the square root of, may I use now the red ink to distinguish it? So 1 over the square root of 1 minus x squared. Okay, so this is the formula for arc sine. Okay, were we able to show that derivative? Okay, derivative of arc sine of x is equal to, there, 1 over 1 minus x squared. Okay, now let's apply. Now, before we proceed to proving the rest of the formulas, let's take an application. Let y be equal to arc sine of x squared minus 1. Okay, so let y be equal to arc sine of x squared minus 1. Find y prime. Find y prime. Okay? So, looking at our function given, this takes the form sine or cosine, arc sine rather, of u. Arc, yes, arc sine of u. Okay, arc sine of u. And what did we say? If u is differentiable by chain rule, we have to differentiate u with respect to x. So, in this case, x squared minus 1, okay, we let u be equal to x squared minus 1. And du, we let du be equal to, differentiating x squared minus 1 gives 2x. Okay, so going back to our formula, y prime equals, okay, look at this. 1 over the square root of 1 minus u squared times du over dx, or times du. Okay, so let's proceed. So your y prime takes the form 1 over the square root of 1 minus u squared times du. Or simply, y prime is equal to du over the square root of 1 minus u squared. Okay, what therefore is y prime from here? Du, what is our du? Du is, okay, du is 2x. So, y prime equals 2x all over the square root of 1 minus, what is our u? This. Okay, and our u is this one. 1 minus, okay, x squared minus 1 squared. Or if you want to simplify, it's okay, but this is already correct. So this is the proof of the first formula. How about the second? For arc cosine, let y be equal to arc cosine of x. Okay? Arc cosine of x, or y is equal to arc cosine of x. Which means that x must be equal to, or y rather, cosine y rather, that cosine y is equal to x. Again, and then again, apply implicit differentiation. Derivative of cosine. Okay? Derivative of cosine from our previous lecture is negative. Yes? So, negative. Okay? Negative sine y dy over dx equals, okay, equals derivative of x is 1. So, dy over dx is equal to, okay, negative 1 over sine y. Okay, negative 1 over sine y. Just the same, looking for sine y. Okay, look for sine y by, again, like what we did a while ago, from here, okay, draw a right triangle and assume, let's assume that one of the acute angles is angle y. So, from here, I would have to write cosine of y is equal to x, or cosine of y must be equal to x over 1. And remember that cosine is adjacent over hypotenuse. Okay? Adjacent over hypotenuse. So if you draw your triangle once again, let this be the right triangle. Okay, this is the right angle. If we let this be the acute angle y, then which side is adjacent to angle y? This one. Okay, this must be x. And the hypotenuse must be 1. Okay? Adjacent, from the definition, adjacent over hypotenuse. Okay? So, x here, 1 here. This side is missing. Applying again your Pythagorean theorem. So, from your Pythagorean theorem, this must be equal to the square root of, okay, c squared minus b squared. C squared minus b squared, or 1 minus x squared. Okay? And since we're looking for sine y, then referring to this triangle, referring to the triangle sine y, once again, sine y is opposite over hypotenuse. Okay? So sine of angle y is equal to opposite. Okay? Opposite side is this. Okay, and hypotenuse is 1. So, sine y is equal to the square root of 1 minus x squared all over 1. Or, okay, so we were able to show once again that dy over dx is equal to negative 1 over the square root of 1 minus x squared. Okay, so this is the formula for arc cosine of x. But if the argument is no longer x but a function which is differentiable, then apply the general form times du over dx. Okay, I hope this is clear. How about arctangent? Okay, let's prove also the formula for arctangent. Okay, so for arctangent of x, its derivative is 1 over 1 plus x squared. Now, let's show the proof. Okay, the same way as we proved the sine and arc cosine and arc sine, we let y be equal to arctangent of x. Okay? Arctangent of x. So, which means that tangent y must be equal to x. Okay? Tangent y must be equal to x. And then again, applying implicit differentiation, derivative of tangent from our previous discussion is equal to secant squared. Okay, so tan y has the derivative secant squared y dy over dx is equal to derivative of x is 1. Okay, equal to 1. Now, solving further for dy over dx, dy over dx is equal to 1 over secant squared y. Okay? Secant squared y. But what is 1 over secant squared? Okay, secant squared. Take note that 1 over secant y is equal to cosine y. Yes, 1 over secant, because this is 1 over cosine y. And if you get the reciprocal of the denominator and proceed to multiplication, you'll end up with cosine y. Okay? Again, let me write that. This is the same as 1 over cosine y, which is equal to 1 times cosine y over 1, or this one. Okay, so which means that this, okay, going back, this is equal to cosine squared y. Okay, 1 over secant squared y is equal to cosine squared y. Okay, again, we will look for this. Okay, looking for this basing from here. Okay, from here, draw a right triangle. Okay, so from tangent y is equal to x, and TOA, tangent is, okay, opposite over adjacent. Okay, opposite over adjacent. In fact, x could be written as x over 1. So again, let's assume that one of the acute angles of the right triangle is y. Let y be one of the acute angles. So opposite y, x, and adjacent to y is 1. Okay, so what will this be? The hypotenuse this time is missing. This one is missing. So the hypotenuse, which is c, is equal to c squared equal to a squared plus b squared. Again, from your Pythagorean theorem, c squared equal to 1 plus x squared. Okay, 1 plus x, 1 squared plus x squared. So c equal to, okay, c equal to the square root of 1 plus x squared. But what are we looking for? What are we looking for? This one. Cosine squared y. So from here, define your cosine. Cosine y is equal to adjacent 1 over, okay, the hypotenuse c is square root of 1 plus x squared. Okay, so this is equal to this 1 over the square root of 1 plus x squared, all raised to the second power, which gives 1 over, this will now be eliminated. Okay, the radical sign gets eliminated because of the square. Okay, so over 1 plus, okay, over 1 plus x squared. Okay, so we were able to show again that the derivative of arctangent of x is equal to, yan, 1 over x squared. This is what I'm telling you. You don't have to memorize. If you have mastered your trigonometry, you will be able to derive all the rest of the inverse trigo formulas. Okay? Now, I leave the proof of the derivative of arcsecant, arccosecant, and arccotangent to you. Okay? For your assignment. Now, let's move on to applications. Okay, let's begin with problem number 1. Arcsine of x cubed. Okay, so for problem number 1, your argument, the argument, let me write that word. Okay, the argument is x cubed. So this must be arcsine of u. Arcsine of u. So we let u be equal to x cubed. And du is equal to derivative of x cubed from your power rule is 3x squared. Okay, so we are ready to get y prime. Derivative of the given, which is y prime, is now equal to, let me write here. So if your function is of the form, okay, y equal to arcsine of u, then its derivative y prime is equal to 1 over, or du rather, du all over the square root of 1 minus u squared. Okay, or going back to our formulas, list of formulas, there it is. Okay, 1 over the square root of 1 minus u squared times du. Okay, or you can just write du here in the numerator. Or simply du over 1 over the square root of 1 minus u squared. So going back, okay? Okay, so y prime is equal to du, okay, from here, okay, du, which is 3x squared all over the square root of 1 minus your u, which is x cubed. Okay? 1 minus x cubed raised to the second power. So, simplifying it further, y prime is equal to 3x squared all over the square root of 1 minus x raised to the 6th power. And that's it. Okay? Now, we proceed to the next problem. Okay, what about this? Y is equal to 1 over arc sine of negative x. Y is equal to 1 over arc sine of negative x. Now, if you have this function, okay, let's look into another function, not that one yet. 1 over sine x. If you have 1 over sine x, you could express this as, okay, you could express this one as y equal to cosecant x, yes? Or sine x raised to negative 1. Correct? Will the derivative be equal? Okay, now from your rules of differentiation from trigonometric function, derivative of cosecant x, if you could recall, is equal to negative cosecant x cotangent x. Yes? Let's see whether we will end up with the same answer. So if we have this written to be cosecant x, so if you express 1 over sine x into cosecant x, from your differentiation of trigonometric function, y prime of cosecant x is negative cosecant x cotangent x. Okay? So, this is for this. How about if I express it as sine x raised to negative 1? Will I end up with the same answer? Let's see. Then y prime applying what? The GPR, generalized power rule, because this takes the form, this one takes the form u raised to n. Okay, u raised to n. So, negative 1 or negative of sine x raised to, subtract 1 from the exponent, raised to negative 2 times the derivative of sine x, which is cosine x. Okay, or we can rewrite this into negative cosine x all over. Okay, to make this positive, I should bring down sine x. Okay, raised to the second power. But I could factor this out into, I could express this in fact into negative 1 over sine x times cosine x over sine x. Question, what is 1 over sine? Okay, what is 1 over sine? Isn't it cosecant? Okay, so y prime is equal to negative cosecant x. And how about cosine over sine? Okay, what is cosine over sine? You know very well that cosine over sine is cotangent x. Let's compare now. Let me enclose it in a... Okay. Let's compare. Are they the same? Comparing this with the previous answer, correct? Okay, negative cosecant x, cotangent x, negative cosecant x, cotangent x. So this is how important your previous math subjects are. Okay, you have to be very skillful at simplifying. Okay, you should know very well your trigonometric function. So going back to the given. Okay, so 1 over sine, what did we do here? 1 over sine x, we expressed it as sine x raised to negative 1. Okay? So, for number 2, how shall we do it? We can also express 1 over arc sine of x as arc sine of x raised to negative 1. Okay? So that this is also of the form u to the n. Okay? So this is also of the form u to the n. So we have to apply the GPR and the chain rule. So apply GPR. Chain rule. Okay? Because we express this could be expressed as u raised to n. Okay? U raised to n. Okay, so let's apply the GPR here. Your u, however, your u is arc sine of x. Okay? So your u is arc sine of x. And du of arc sine, derivative of arc sine of x, is 1 over the square root of 1 minus x squared from our rules. Now, going back to the function given. However, our function is, okay, u raised to negative 1. Okay? Our function is u raised to negative 1. So, applying your GPR, the generalized power rule, y prime now is equal to exponent negative 1, okay, negative 1 times u, which is sine or cosine, arc sine rather of x, raised to exponent minus 1, so minus 2, times derivative of u, which is this 1 all over the square root of 1 minus x squared. Okay? Now, simplifying it further, y prime is equal to negative, okay, bring this down, 1 over, okay, arc sine of x, okay, raised to the second power times 1 over the square root of 1 minus x squared. Or finally, we could put this together into negative 1 all over the quantity sine raised to negative 1 or arc sine of x squared times the square root of 1 minus x squared. Okay? So, this is our final answer. Now, moving on to problem number 3. Okay, problem number 3. Find the derivative of the function f of x is equal to x arctan of the square root of x. F of x is equal to arctangent of x, rather, arctangent of the square root of x. Okay, now looking at the given, the function is a product between, okay, the product of x and arctangent of the square root of x. So in here, we have to employ our product rule. Okay, product rule. Again, let's recall. Let me write on this side so that you can we can easily follow. If the function takes the form f of x times g of x, or u times v, where u and v are differentiable functions, u times v, what did we say about y prime? Its derivative is the first times derivative of the second, u times dv plus, okay, v times du, u dv, v du. So, y prime is equal to u times dv plus v times du. Okay? So, let's identify our u and v from here. Our u is x. Okay, let u is x. So, differentiating your u, du is equal to 1. Okay, next, our v is, okay, arctan of the square root of x. However, we can rewrite, okay, the radical into its exponential form as x raised to 1/2. Okay, arctan of x raised to 1/2. So, dv is equal to, okay, going over your list of formulas for inverse trigonometric function, what is again the derivative of arctan? Arctan, okay, is equal to 1 over 1 plus x squared. However, the argument here, the argument is not x, but x raised to 1/2. Or the square root of x. So, we have to apply the general form, which is du over 1 plus u squared. Let me write that also here. So, we will have a guide. So, if your function is y equal to arctan of u, then y prime is equal to du over 1 plus u squared. Okay? 1 plus u squared. In here, our u is this. Okay? Our u is x raised to 1/2. So, let's apply this then here to find dv. Okay? To find dv, okay, first we have to get, or maybe 1 minute. Let me, 1 over 1 plus u squared times du over dx. Okay, 1 plus u squared times du over dx. So, derivative of arctan, therefore, is equal to 1 all over 1 plus x raised to 1/2 raised to 2 will be x raised to 1. Correct? Let me make it bigger so you could see it clearly. 1 plus x raised to 1/2 raised to 2 times derivative of this, derivative of x raised to 1/2. Okay, here times du over dx times the derivative of the argument. So times, applying power rule, derivative of x raised to 1/2 is 1/2 x raised to negative 1/2. Okay? 1/2 x raised to negative 1/2. So, finally, we could write dv as, okay, 1 all over, okay, 1 over 2. This, what happens here? This becomes 1 plus x, yes? Okay, 1 over 2 times 1 plus x square root of x. Okay, correct? 1 plus 2 times 1 plus x square root of x. Now, let's continue. Okay, let's proceed from here. F prime of x, therefore, is equal to, now going back, we said a while ago that the given takes the form, okay, it takes the form uv. So its derivative must be applying the product rule u dv plus v du. Okay, so u is x, dv the whole of this. Okay, x times dv. May we have it below so that we'll have enough space. X times, let me copy from here, u dv, ito, dito, 1 all over 2 square root of x times 1 plus x. Okay, so that's u dv plus v du. Okay, so we're done with this. We're done with u dv, sorry. u dv, we're done with the first. So now moving on to v du. Plus v, which is, okay, arctan, okay, arctangent of the square root of x times du, which is 1. Let's continue further. F prime of x, therefore, is equal to x over, okay, x over 2 square root of x times 1 plus x plus arctan of the square root of x. Okay? Or if you wish to simplify this portion here, it's alright, you can do so. If you want to simplify that part, then let me separate. Okay, so f prime of x, therefore, will be f prime of x is equal to, look, x here could be expressed as x raised to 1/2 times x raised to 1/2. Okay? I could write this as x raised to 1/2 times x raised to 1/2, or simply square root of x times square root of x. I could write this as square root of x times square root of x. And what happens? This with this will cancel out. Okay? So what remains? The square root of x all over 2 times 1 plus x. Okay? Plus arctangent of the square root of x. Okay, that's it. Okay, so that's the final answer. F prime of x is equal to the square root of x all over 2 times the quantity 1 plus x plus arctangent of the square root of x. Okay? Now, we move on to problem number 4. Okay, this time, we have arctangent of, y is equal to the square root of the arctangent of 2x. Okay? Y equal to the square root of arctangent of 2x. Now, for functions involving radicals, we often transform it first into exponential form before differentiating. So let's do the same for y equal to the square root of, arctan of 2x. So let's express this as y equal to arctangent of 2x raised to 1/2. Okay? So this one will require chain rule and inverse trigo function. Okay? So this takes the form u to the n. Again, it takes the form u to the n, wherein your u is arctan of 2x. Okay, your u is arctan of 2x. So let's answer together. So since your y takes the form u to the n, we have to apply power rule. So y prime is equal to n exponent 1/2 times u arctangent of 2x raised to exponent minus 1, so negative 1/2 times derivative of this. Okay, so here your u, is arctangent of 2x. Okay, arctangent of 2x. But the argument is not simply x, but 2x. Which means by the chain rule, we still have to get derivative of 2x. So your du must be, so du must be equal to, for arctangent, once again, is 1 over 1 plus u squared times du. So 1 over 1 plus u, referring to the argument, this one. Okay, so 2x raised to the second power times derivative of 2x, which is 2. Okay, so du must be equal to 2 over 1 plus 4x squared. Okay, so what shall we write here now? Our du. Okay, so nu to the n minus 1 times du. Because if the function takes the form y equal to u to the n, y prime equal to nu to the n minus 1 times du. Yan yung power rule natin. So times du, which is 2 all over, 2 all over 1 plus 4x squared. Okay? Now, what happens to 2 and 2? 2 in the numerator, in the denominator cancels out with 2 in the numerator. So your y prime then is equal to, now we move this to the denominator, giving 1 all over the square root of, arctangent of 2x times 1 plus 4x squared. Okay, that's it. Okay, so y prime is equal to 1 over the square root of arctangent 2x times 1 plus 4x squared. So this is our final answer. Problem number 5. Now let's look into problem number 5, number 6, number 7, number 8. I think okay, I'd like to answer number 8 or before number 8, because I'm leaving some items for your assignment. I leave number 5 as your assignment. Okay? Item number 5 will be for your assignment. Let's have number 6. Okay, let's answer together problem number 6. Y is equal to x, arc cosecant of 1 over x. Okay, y equal to x, arc cosecant of 1 over x. So looking at the form, okay, what rule are we going to apply aside from inverse trigonometric function because of arc cosecant? Okay, look at the given. It takes the form uv. Once again, this is a product, u times v. Okay, so your u is equal to x. This is supposed to be assignment, but I want that we answer it together. Instead of number 6, you answer number 5. Okay, so u is equal to x, and your v is, let your v be arc cosecant of 1 over x. Okay, so du equals 1. And dv, look at dv. And the argument is 1 over x. Okay, arc cosecant of 1 over x. Okay, let's go back to our list of formulas for inverse trigo. If the function takes the form inverse, or arc cosecant u, what is y prime? Okay, what is y prime? Okay, go back to our list of formulas. Okay, here. Okay, derivative of arc cosecant of u is negative 1 over absolute value of u times the square root of u squared minus 1 times du over dx. Okay? So, negative 1 over absolute value Okay, so negative 1 over absolute value of u square root of u squared minus 1 times du over dx. Okay? So, dv is our cosecant, or dv rather, v rather, is our cosecant of, instead of 1 over x, I have to write it in exponential form as, okay, let me write it as x raised to negative 1. Okay? X raised to negative 1. It's easier to get the derivative if it is expressed in that manner, if it's written in that manner, x raised to negative 1. So, applying this then, negative dv will be from here, okay, from here. dv will be equal to negative 1 over, okay, absolute value of u, which is our u, this one, this is our u, okay, u, the argument, okay, negative 1 over the absolute value of 1 over x times the square root of, okay, u squared minus 1. Okay, the square root of u squared, which is 1 minus, or 1 over x squared minus 1 times, okay, this part, du over dx. Okay, derivative of the argument. Let's make it bigger. Times, okay, derivative of x raised to negative 1, which is negative, okay, x raised to negative 2. Or when simplified further, what is dv equal to? It will be 1 over, okay, 1 over absolute value of 1 over x times x squared times the square root of 1 over x squared let me make it bigger, the square root of 1 over x squared minus 1. And we can simplify this further as, okay, inside the radical sign, okay, we could simplify this as 1 over x squared, square root of 1 over absolute value of 1 over x, or 1 over x. Later we could cancel out. Square root of, if you simplify 1 over x squared minus 1, what will it be? 1 minus x squared, correct? All over x squared. Okay? Okay, or dv is equal to, this could be cancelled out with this 1 and this, okay, x, and this one, if you take the reciprocal, if you get the reciprocal of this, now wait, if we get the reciprocal, then this becomes square root of x squared. In fact, if we get the reciprocal, it will be of this, I'm referring to this radical, if we get the reciprocal, it will be the square root of the square root of x squared all over 1 minus x squared. Okay, which when simplified further will be equal to, in fact, we could bring this out. Now, before let me make it bigger so that you can follow. Saglit. May I erase this first? Okay, we have it here. Meantime. Okay, so from here, dv will now be 1 all over, let's leave it that way muna, 1 over x, absolute value, times x squared. If I combine this, I'll end up with a fraction inside. The fraction will be 1 minus x squared all over x squared. Okay? That's combining this. 1 over x squared minus 1 is the same as 1 minus x squared all over x squared. And take note that if we extract the square root of this, okay, what do we get? We extract the square root of the denominator. This will give us dv equal to 1 over the absolute value of 1 over x times x squared times the square root of 1 minus x squared over x. This one will cancel out. Okay, this will cancel out. This with this. I hope you can follow. Okay, so that your dv will now be simply 1 all over, okay, 1 all over x, 1 over x absolute value times the square root of 1 minus x squared. Okay, so going back to number 6, then y prime is equal to u dv v du, u dv u x dv, the whole of this. Okay, dv is the whole of this. 1, okay, 1 all over x times the absolute value of x, square root of 1 minus x squared, plus, this is u dv plus v du, v, r cosecant of 1 over x times du is 1. Okay, simplifying it further, y prime equal to, what happens with x? X with x will cancel out. So what is left? 1 over absolute value of 1 over x, square root of 1 minus x squared, plus cosecant squared, or r cosecant rather, of 1 over x. Okay, so that's it. Okay, so final answer is y prime equal to 1 over absolute value of 1 over x times the square root of 1 minus x squared plus cosecant, r cosecant of 1 over x. So, I leave then problem number, let me encircle. I have uploaded this in your Lens account already. Number 5. Okay, let me encircle. Problem number 5 for assignment. Problem number 7. And problem number 8. Okay, so problem number 5, 7, and 8 for your assignment. Are there questions before we end the session? Reaction. Okay. So if there are no questions, then that's the end of the session. So for next session will be hyperbolic functions and your exponential and logarithmic functions. Okay? Goodbye, everyone.